Well, good afternoon, everyone. Happy Friday. My game today got switched from a home game to an away game, so that's why I am not here. So if you take out your homework from Wednesday, we're going to go over that, and today's lesson will just be a video lesson. It'll be exactly what I taught earlier today, so you should be able to keep up with no problem. So the homework from Wednesday, these were where you would show the work. Like, for example, square root of 28 on this one, number one, you would show the square root of 25 is 5, the square root of 36 is 6, and we know it's closer to 5. The answer was actually incorrect. The answer for this should have been, I'm not sure why the book put that, 59.3 swings. All right, so these were the same thing where you would just show the two that are closest. All right, so this number 9, we know the area is 345 square feet and it's a square. So that means that the two sides are x by x. Area is length times width, so that's x squared equals 345. What that means is, what can you square to get 345? Well, that's what a square root is for. So you would just go to your calculator and type in the square root of 345, which gives you 18.57. The question says, how much fence do we need? You're only fencing 3 sides because it has a shed along here, so you don't need fence along this side. So it's just 3 times 18.57, which gives you about 56 feet. Number 11, again, make sure you understand how to use your calculator and you're getting this answer. When you're dividing by 4, make sure you put the parentheses around both sides. We talked about that on Wednesday. 12 and 13, you would make them the same. You could make them all square roots. Like if you work backwards, 7 would come from the square root of 49, 9 would come from the square root of 81, and then it's really easy to compare them. Sometimes it's easier to use your calculator and make them into a decimal. So for number 13, I would make them all into decimals just by using my calculator, and then that would be the easiest way to compare. When you write them, put them in the original, like write them as the way they're originally written in the question. Number 14, if I know it's a cube, that means all 3 sides are the same. My formula for volume is length times width times height. So my volume is x times x times x. It tells you the volume is 4. So what can you cube to get 4? That's the definition of a cube root. What can you cube to get 4 is the cube root of 4. So the cube root of 4 using my calculator would be 1.59. The question is, can you fit this cube on a shelf that's 12 inches? Well, 12 inches is 1 foot. This is 1.59 feet. This is clearly too big. It won't fit on a shelf that's only 12 inches tall. All right, and the same thing for like 29 and 30. You're saying, what can you cube to get 210? That's what a cube root is for. That's the whole purpose of a cube root. What can you cube to get 210? You would take the cube root of 210. And the last one, it tells you he's buying grass seed. The 2-pound bag will cover 1,000 square feet. Estimate the side length of the largest square if he purchases 5 bags. So that means his total area is 5,000 square feet. So we're saying x by x, again, it's a square. So what can give you an area of 5,000? So that's what the square root is for. So the square root of 5,000 would be about 70.7. So about 71 feet on each side. All right. If Mrs. Asciola or the substitute, whoever's filling in for me, did not pass out the blue note sheet, you can ask them to pass that out now. But you should be referring to your blue note sheet. So the last section in this chapter is section 110 on real numbers. Our quiz, remember, is Wednesday. So you can go ahead and write this in. So the real numbers are the set of rational and the set of irrational numbers. If I go too fast through any of this, just feel free to pause and get caught up. That's the nice thing about the video lesson. You can pause and go at your own pace. We did rational numbers way back in the very, very first section of this book. Section 1.1 was talking about rational numbers. So this next section is not brand new. So rational numbers can be expressed as a fraction, which means it's a ratio. It's got the word ratio in here. So examples of rational numbers would be like just -3, because you can write that as a fraction. You could put it -6/2. It could just be a positive number. 9. 9 you could write as a fraction. You could make it 90/10. If the decimals stop, you could say this is -6 2/10. This is the tenths position. So you could make that into a fraction. So write all of these examples down. Again, if I'm going too fast, just pause. If it repeats, you can make it into a fraction. Remember, we can put this over 99. So that's a fraction. Rational means you can make it into a fraction. A fraction is obviously rational. It's a fraction. And a square root of a perfect square, we could change this into 6. So then it's really exactly the same as something like this. New in this section is a group called irrational numbers. And that prefix, you probably know from English, means the opposite. So it cannot be expressed as a fraction. So rational means you can write it as a fraction. Irrational means you cannot write it as a fraction. Examples of irrational, I think we talked about some of these, would be a square root that's not a perfect square. So like the square root of 36 is a perfect square. You can write that as 6, which can turn into a fraction. A number that's not one of those perfect squares is irrational. Pi, I believe we did talk about, that would be irrational. You cannot write that as a fraction. And the other type would be a decimal that goes on forever but does not repeat. So if it goes on forever but does not repeat, that would be irrational. So that would be something like, I think in chat in section 1 we did like maybe 0.1234 ... It doesn't have to be exactly like that. This is something that you can clearly see the pattern. So a pattern is different than repeating. The 1.811, 8111, 811111. It doesn't repeat, but it clearly doesn't stop. So that would be irrational. So at the bottom of your blue paper, you have a giant Venn diagram which just categorizes. It gives you a place to put each category of numbers. So the real numbers are every number you've ever studied. Over here, the new group would be the irrational. So that would be like pi, the square root of 30. That's not a perfect square. Like the 0.1234 ... etc. So that would be the group of irrational. And there's lots of those. There's an infinite number of those. Over here, the whole numbers would be in the center. And we did this group before. Again, this is just a quick review of these numbers. So the whole numbers would be like 8. Anything that's not negative could be 0, no decimals, but it can't be negative. The next group was the group of integers. We've been using that word a lot. Integers would be, it does include these. Again, this circle, this inside circle is also inside the integer circle. But the numbers that are not whole numbers that are integers would go here. That would be like -4. So those are the integers. They're not whole numbers. I'm sorry, they include the whole numbers, but these other numbers, the negatives that are not whole numbers, would go here. And the last part would be like fractions, so like a half, 0.4 repeating. So these would be all the rational numbers. So rational does include the integers, and it does include the whole numbers. Everything inside of this left half would be a rational number. So whole numbers are rational, integers are rational. Okay, again, if I'm going too fast, just pause. So if you flip over to the back, there are 10 numbers listed there. The directions say name all sets of numbers to which each number belongs. And you can abbreviate, you can use W for whole, INT for integer, RAT for rational, and IRR for irrational. So pause the video and then go ahead and try those 10 on your own. Okay, so hopefully you paused and now you're finished with those 10. So let's just go through these. Let's start with the irrational. So I know pi is irrational. I know if it goes on forever and doesn't stop. So number 4 is irrational. I know square roots that are not perfect square roots. That would be 5. So those are the irrational. So now let's go to the whole numbers. Now the reason I'm going to start with the whole numbers is because if it's a whole number, you see how if it's inside of this dot, it's also inside of the second circle and it's inside of the third. So it's never going to be whole number just by itself. If it's whole, it's also integer and it is rational. So let's find a whole number. The square root of 49 is 7. That's a whole number. So if it's a whole number, it's also an integer and it's also rational. 8 and 0, number 10, would be the same. If it's a whole number, again, it's inside of the whole number circle. One more time, let me go back here. So if it's a whole number, it's inside of the integer circle and it's also inside of the rational. So whole number is always an integer and it's always a rational number. All right, let's find integers next. Integers are also inside of the rational part. So integers, the only integer we have would be number 9. So if it's an integer, it's also rational. Again, you can make it into a fraction. That's what rational means. You can make it into a fraction. All right, and the rest of them should then be numbers that you can just make into a fraction, but they're not whole or integers, which means they're just rational. You can make this into 37 over 99. It repeats. You can make this 8 and 2 over 10. So it's a fraction. Number 7 is already a fraction. If you study these, they're really not that difficult. And if you sort of look for one group at a time, like I just did, like look for the irrational, look for the whole numbers, etc. All right, the rest of what we're going to do today, you can use your calculator and we're just going to compare numbers using less than, greater than, or equal to. So all we're going to do is change these into decimals. That's probably the easiest way. So just ignore the negative when you type this in on your calculator, but go ahead and type both of those in on your calculator. Pause the video. All right, so hopefully you change both of these into decimals. This would be negative 3.873. It keeps going, but let's just see if we have to go further, we will. But this side, if you use a calculator, we just divide 7 by 8, gives you negative 3.875. Since they're negative, I have to be careful. So every digit is the same except for this one. This is the bigger number, which means it's further left. So if it's farther to the left, that means it's a smaller number. So the correct symbol here should be greater than. All right, go ahead and try number 2. Pause the video and try that one. All right, so percent means how many out of 100. So this is 12.3 out of 100. So we have to assume that you remember some basic stuff with percentages. My lights are going off here. All right, so 12.3 out of 100, you can then just make that into a decimal, which would be 0.123. You do have to show work when I check your homework on Monday. You do have to show like these decimals that I have here for number 1. You have to show these decimals here. So this is 0.123. If you know that you just move the decimal point twice for a percent, that's fine too. Type this in on your calculator. So that would give you 0.187. This one on the right is clearly bigger. So my answer here would be less than. All right, we talked about this the other day. Which point is negative 14.5? So this would be negative 13. You don't have to write this. This is just pay attention to this. This is negative 13. This would be negative 15. So negative 14.5 is between these two. So it would be point A, not point B. Again, you don't have to write that. All right, so we've been graphing dots on number lines the last few days, sort of leading up to this. So now I want to order this set from least to greatest. All right, so sorry, I have some incorrect numbers on your paper. So change the negative 8 and 5/6 into the yellow highlighted ones. So keep the first two and then change the last three. I apologize for that. So make the negative 780%, the negative 9 and 5/6, and the negative 9.41. All right, so go ahead and change all of those into a decimal. Pause the video and then restart once you've made them all into a decimal. All right, so this is negative 8.89. As a decimal, this is negative 8.19. So this is 780, negative 780 out of 100. That's what percent means. So this would be negative 7.8. This is negative 9.833. And this is negative 9.41. Repeating. So that's a repeating bar over there. Sorry if that doesn't look like it. So negative 9.41. So this is negative 9.414141. All right, so let's just order these from least, smallest, to biggest. Okay, so the smallest one would be the one furthest to the left. Furthest to the left, so this is going to be our smallest one. I'll just number that number 1. Because it's negative 9.8, it's further to the left than this one. So this is going to be our second one. The next one would be, so this is going to be our biggest one, negative 7.8. That would be the fifth. If we're going from smallest to biggest, this is going to be the biggest because it's closer to 0, heading from negatives to positives. All right, negative 8.89 is further to the left than negative 8.19. So this is going to be our third, and this is going to be our fourth. So let's just write them in the original order. So negative 9 and 5/6, comma, negative 9.41 repeating. Third is negative square root of 79. Fourth would be negative the cube root of 550. And the last one, number 5, would be negative 780%. So that's part of what we did. We did most of the work. So let's reread the directions. The directions say order the set from smallest to biggest. The easiest way, again, is to make them into decimals. So we just did that part. Now it says verify your answer by graphing on a number line. So now we just have to put these numbers on a number line. You only have to graph integer like places. You don't have to put decimals as your scale here. Your scale should just be integers. Okay, so go ahead and make that scale. You can just put in the same 5 numbers I have. All right, and then let's just put these where they belong. So the smallest was negative 9 and 5/6. That's negative 9.8333. Let me change my color here. So that's almost to negative 10. So I'll just put here negative 9 and 5/6. The next will be negative 9.414141. That's a little bit closer to 9, not much, but it's between here. So this will be negative 9.41 repeating. Third was the square root of negative the square root of 79. So that's negative 8.89. So that's almost to negative 9. So that would be negative square root of 79. Next is the cube root, negative the cube root of 550. So that's negative 8.19. So it's on to the left. We're heading between negative 8 and negative 9. So that would be negative cube root of 550. And then the last one was negative 780%. Again, that means how many out of 100? So that would be about here, between negative 7 and negative 8. That would be negative 780%. Again, pause if you need to see that anymore. Last question. On a clear day, the number of miles a person can see to the horizon is about 1.23 times the square root of their distance from the ground in feet. John is on the observation deck of the Empire State Building at 1,250 feet. Write the formula first, then calculate how far John can see. Okay, wow. So we have to make an equation out of this. Let's read it again. On a clear day, the number of miles, let's just make the number of miles, let's just use M for that. So the number of miles a person can see is about 1.23 times the square root of their distance from the ground. So let's make the distance from the ground D. So we have to make a formula, so we're going to have letters. So the number of miles is M. The distance from the ground is D. Let's read it one more time. The number of miles a person can see, so that would be M, is equal to 1.23 times the square root of their distance from the ground, so times the square root of D. Read that again. Hopefully that makes sense. So the miles is 1.23 times the square root of the distance from the ground. Now we just have to plug in once we get the formula. We've just done the difficult part. So I plug in. I get the miles is 1.23 times the square root of 1250. So the number of miles would be 43.5 miles. All right, your homework is two things. There's book problems and the worksheet, so you can have the substitute pass out. The substitute can now pass out the gray worksheet and these problems in the book. Hopefully you can finish a lot of that before you leave, but that is your homework for this weekend. Have a great weekend.